In this video, we will review the strategy we learned in class for simplifying radicals. Before we can review simplifying radicals, though, we need to review our list of perfect squares. We know that the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8, the square root of 81 is 9, the square root of 100 is 10, the square root of 121 is 11, and the square root of 144 is 12. Now there are a lot of other perfect squares, and if you forget any of these, you can always apply our longer method to simplify these radicals, and you'll end up with these numbers. It just makes our life a lot easier if we can immediately recognize some of our perfect squares. So if we look at our first example, 36 is actually a perfect square. So we can go straight to our list, and we see that the square root of 36 is 6, and we're done. Once again, if you forget, you can apply the method we're going to do in the next problems to simplify that radical as well. So let's look at the square root of 98. The first thing that we are going to do is our factor tree. So our factor tree is going to be 2 and 49, and we know 49 is 7 times 7. Remember that you can use a calculator, and you start by dividing by your small numbers and slowly get bigger to help you build out your tree. When I'm making a factor tree, I circle every prime number because each branch should end in a prime number, and that's what's going to go as our prime factorization, so 2 times 7 times 7. You notice the 49 is not in that radical because it is not a prime number. Now we are going to circle our pair. We know that 7 times 7 is 49, so I'm going to evaluate the square root of 49. We know the square root of 49 is a perfect square, so that gives us 7. And then this 2 is still inside of our radical, and we get 7 root 2. Notice that our radical does still have a value in it because 98 is not a perfect square. And you notice that we did actually evaluate the square root of 49 to get 7. Let's try that on another example. 104. Now, I don't know all of the factors of 104 off of the top of my head, but I do know that it's even, so I should start with a 2. And if I were to use my calculator, I could divide this by 2, and I would get 52. Once again, I'm not sure what all the factors are, but I see this is another even number. So I'm going to pick 2, and when I divide this by 2, I get 26. You notice that every step I am circling my prime number. Now 26 is 2 and 13. 2 and 13 are both prime numbers. Now that every branch ends in a prime number, I can create my prime factorization as 2 times 2 times 2 times 13. Now there is only one pair of identical numbers. I cannot circle any other pair without overlapping this one. So this is all that gets circled. And then these two are going to have to stay inside of our radical because they do not create a perfect square. But 2 times 2 is the square root of 4. And if we look at our list, we know that the square root of 4 is 2. So this becomes a 2. And then inside, I still have 2 times 13. But we're not done yet. I do want to multiply 2 and 13 together. And our final answer will be 2 square root of 26. And we can leave that like that. Thank you very much and have a great day.